This is a production of Cornell University.
So good morning, everyone. Obviously, this is not my main line of work. I don't do a lot of presentations, so I'm going to do the best I can to work through this. As Jenny said, I've been working for about 25 years with dairy farms all over New York State on both environmental and facility planning projects. So we do a lot of manure storage design. I'm going to go ahead and go through a little bit of an outline of what I'd like to discuss. Since we do a lot of storage design, I wanted to talk a little bit about storage design considerations and how that can affect the cover design and what types of storages are easier to cover and site limitations that prevent some of those easier to cover options sometimes. We're going to talk about storage cover design considerations. Obviously, what type of storage you're covering matters, but also what are your goals for your cover? Oh, sorry. Some examples of new storages with covers in mind. Manure transfer in and out. The siting and the topography of that manure storage is going to matter a great deal. Examples of some retrofits and issues encountered after installation. So first, we'll go talk about the storage general design considerations. Obviously, when we're sizing a storage, or when we're designing a storage, the very first thing that matters to us as engineers is size. What is the capacity we're going to need? What type of animals do you have? What type of waste are they generating? Other sources other than just the standard manure that you're going to be putting into this system, including, say, for Dale on a dairy farm, you're looking at milking center waste, likely silage leachate control, things that are going to affect the overall size of that storage. Bedding material also affects what this storage is going to look like tremendously. You heard Dale kind of talk about a few different types of bedding they've used in the past. One that is pretty popular in New York State is sand. Sand bedding does affect a manure storage design more than any other type of bedding. So if you bed with sand, you either have to have a very extensive sand separation system, or you need a way to get into your manure storage and remove that sand. If you're bedding with solids and sawdust, you can re-agitate those materials from above and don't necessarily need the access to the manure storage. You also notice that Dale pointed out, rightly so, that separation is a huge part of any system that's going to have a cover in it. So is that something that you're willing to look at? Site conditions. We look really closely at those in New York State, especially because NRCS has come out with new requirements, relatively new within the last 5 years. If you're over certain types of bedrock or over aquifers, you're required to do an enhanced design, which would either include a synthetic liner or enhanced concrete structure. Sometimes that can limit us on our options for manure storage capacity and location. And then you need to look at some other things. What's your topography? What's that going to do to your storage design? Am I in a hillside? Am I on the flats? Some man-made obstacles that some people don't always think about: overhead power lines and right-of-ways for those, as well as pipelines, give us obstacles to work around and locations. Sometimes we end up having to pump or move a storage where we weren't really planning on because of those issues. And then solid separation, are you planning on doing that? As Dale said, that is something that takes management, operation, and is sometimes cost prohibitive for a smaller farmer to have a solid separation system just for 100 cows or less. And then when we're doing the manure storage, will it be covered? And that's kind of what we're going to go over today. What are the design considerations for that manure storage if it's going to have a cover in place? So storage design considerations, what type of storage? So in New York State, we do mainly 3 types of storages. Earthen, and in that I would consider earthen with both a clay liner and a synthetic liner. So that would be the earthen storage option. Concrete storages, most of those are a vertical walled structure in New York State. And then we do some slurry store type structures, which are the glass fused steel type structures. Each of those structures has their own benefits and drawbacks. With the earthen storage, they're much more easily covered. The concrete storages can be covered in certain situations, but it's a little bit more difficult. And then the slurry store structures tend to have a size limitation, so they can be covered. Slurry store actually makes a cover that goes right on those, but they have a limitation on size of those structures. When you're designing a manure system, think about what your storage pumps. Do you have existing storage pumps? What kind of a riser do you want? Do you want to be able to pump into and out of the storage from a riser? Do you want to pump in and out at surface? Things like that are going to matter to you. Distance to electrical service, which didn't used to be an issue, but if you want to be able to pump out of a riser, sometimes those are an electrical submersible pump. Also, if you're going to be covering a structure, Dale's flare was solar powered, but a lot of the flare companies do prefer to have a direct connect to an electrical service. And also the pumps for the rainwater. Also, it's easier if you have a direct electrical service. You also need to be thinking about sources of contamination near the cover. So Dale's storage is next to his bunk silo. There is a potential for silage leachate to develop on the cover from silage that is blown on from the bunk silo that's adjacent. You also could have issues with bedding solids. If your bedding solids building is near your cover, those are some things to keep in mind. And then gas collection and potential flare location. So the gas collection needs to be calculated carefully. So when you're designing your system, you have to design it for a certain amount of gas that's going to come off, calculated based on the number of animal units going in and ambient temperature. Sometimes you can need a blower to deliver the gas to the flare. The other thing to think about is that gas is a wet gas. So in order to send it to the flare, you need to run it through a condensate trap. And it's beneficial if you can put that flare upslope from the manure storage so that when you run the gas through, you can actually gravity the condensate back. And then water exclusion. We've talked about the rainwater and the pumps out of the system, but you also need to make sure this goes for a manure storage or a covered manure storage, that your clean water exclusion system, which may include a diversion upslope, is functioning well and designed appropriately. And we'll go over that a little bit later. I'll talk about a cover that was put in, and then we immediately had 5 feet of rainwater on top of it due to one of those large storms we seem to be getting in New York State anymore. So I think what we'll do now is go through a cover installation, kind of start to finish. This is a cover that was installed in Erie County. Alan Young from Erie County Soil and Water took all of these pictures for me during installation. This was a retrofit on an existing manure storage, and we'll kind of just go through the steps that were taken on this particular storage first. I'm going to use my mouse here. So this picture up here in the upper left-hand corner is a manure riser and pipe into the bottom of the structure. So one thing to think about when you're doing a manure storage, either retrofit or a new design, is that the cover needs to be sealed. And how are you going to get manure into and out of the structure? This pipe going in on the bottom creates a liquid seal. The manure level is above this pipe. So they can pump in and pull out whenever they'd like without opening the cover or breaking that seal. Over here on the right-hand side, you can see this is the manhole structure, pipe going out of the bottom, and they can introduce from the top or put a pump in the top to pull back out again. Oh, shoot. That just, there. Down here in the lower left-hand corner, you can see they're getting the cover ready for installation. So one thing to think about when you're covering is you need space to be able to weld the cover together off to the side and then pull it over the storage. So you need a pretty big space to be able to accomplish that. Over here on the lower right, you can see that they are welding together. Dale talked about the concrete weights on his cover. So all those are pieces of cover material welded together and filled with concrete to make the troughs to collect the water. This is the, we'll start here actually in the lower left. One of the things to think about when you're putting on a cover is how many solids will be in there. So you're going to have separation, which we talked about. But even when you separate, there are some solids that make it through that system. How are you going to re-entrain those solids if you feel it's an issue? So some separation systems are such that we don't put in these recirculation lines. This manure storage has recirculation lines that you can see go through the bottom of the storage structure and up to the surface. So those get installed first. And then you can see the stabilization trench is put around the outside of the structure. This is fabric just to protect the liner as it goes up and down on the surface, or the cover, I'm sorry, the cover as it goes up and down on the surface. And the pipe you can see here is the gas collection line. You can see it here with strapping that'll hold it in place. And then in this upper right-hand corner, you can also see one of the things you need to think about as well, if it's an existing system, is how do I seal around existing penetrations? This is silage leachate, which I had mentioned before, liquid coming from the runoff at the bunk silo, comes through this pipe. And now because it's buried and will be under the cover, that will create the airtight seal that we need. And it's below obviously below the stabilization trench. That stabilization trench, I'll show some pictures in a minute, but that's where the cover gets anchored. The bottom right here, you can see they're just starting to pull that cover across. So the picture we saw in the beginning was back here, it was staged. They're now pulling it across with equipment. So why am I missing? Hang on. Here we go. They've pulled it across more. They're pulling it across a little bit more in this picture. They float it right across the manure storage when there's liquid in there. So you don't have to have it all of the way empty. You have to have it at a specific level for them to pull it across. That's part of the planning process that Dale talked about. You need to make sure that your liquid level will be at the appropriate level for them to cover when they're able to come. This is the stabilization trench. You can see that the cover goes down in, back up, and then they backfill it with concrete. This is just the cover as it comes all of the way across. And then here it is. Here they are finishing up backfilling that trench. So now that we've done that, I think we'll go through, that was a retrofit. I have just some aerial views of some systems that we've worked on that I'd like to go through, kind of point out some issues that we've had as time has gone on. So this is a manure storage that was designed and the cover installed at the same time, roughly. So I mentioned you have to have liquids in here. So the storage was installed. A liner was put in. This has a synthetic liner, as like Dale was showing you in his photo. And then the cover was put on several months later after the liquid level was such we could float the cover across. So one of the things when you're designing a manure storage with a synthetic liner, you need to design that core trench differently than if it's going to have a cover than if it's not. So if you don't have a cover, a synthetic liner just has a core trench that's backfilled with earth. Whereas if we're going to put a cover on the top eventually, you want to backfill that with concrete. Small changes like that in the design. You also, I talked about the manhole structure. This was designed with a manhole structure from the beginning. So this didn't have to be put in later. There's a manhole structure here, and then the pipe goes out into the bottom of the storage right here. This storage also, because of this manhole structure, and this is an electric submersible pump, this pumps to a remote loadout that's about 1,500 feet away from the manure storage. This farm has a remote loadout here with a self-contained system for spillage. You can also see on this drawing or on this photo the clean water collection here, and then the rainwater pumps are discharging. They do not discharge. Dale discharges and collects. This storage just discharges to the surface the clean water. So we talked about the manhole. This is actually the finished manhole for the project that I originally showed you. It was a retrofit, so this was installed later. They originally pumped over top of the manure storage structure to load and unload, and this was a retrofit to allow us to cover. This is just another version of the same thing, but this is a circular manhole that's a little bit smaller with a circular discharge pipe. And this is another view of that same structure, just to give you an idea what that looks like. You do have to site this so that the cover the stabilization trench for the cover can go between that and the top of the wall of the manure storage. So I'm going to now go through some retrofits. This is the first retrofit that we did in 2009. This is 2 manure storages covered with one. You can see they have solid storage around here, and the liquids from that go into here, and then they covered these 2 storages. So there are some storages because of the solids that will not be able to be covered, or it would be very difficult to cover, but this farm has chosen to cover the ones that were easier to cover. This farm was the very first one we did, and they did not have a way to get manure into or out of the structure without going over the surface, and did not do a retrofit. If you look very carefully where these arrows are pointing, you can see access ports. So when they need to get manure out of this structure, they go and open a port on top of the manure storage and then put the pump in there. You can see the rainwater's collecting, clean rainwater collected here. The ports are, to me, are a little bit of a safety issue because you're standing over the manure storage, opening a port where gases can escape at you when you're opening the port. Prefer the manhole type structures. This is another retrofit done in 2010. You can see the manhole structure here in the corner that was retrofit. So this also was a retrofit. We put the manhole structure in. You can see the stabilization room for the stabilization trench. We try to leave about 5 feet there. This was a earthen line structure, so we had to repair the earthen liner when we put this in. The manhole was installed here in 2010. The other thing when you're installing a cover, it generally discharges to the flare. However, there needs to be an emergency relief valve so that if something happens with this flare, there's a way for the gas to escape the system and not build up. This farm has a circulation manifold here. So he has the circulation lines that I had showed you previously on the install pictures. And he chose to put a manifold together so that he can just turn valves to be able to recirculate manure through his system. This is another retrofit done in 2011. On this one, you can really see the gas buildup just because of the time of year that the photo was taken. This also has a retrofit for the manhole and line in that was installed. A lot of the storage is built in the early 2000s, late 1990s. Had an over the bank discharge into the storage and then just a pump drive in to pull manure out. This is the flare location. Flare location needs to be at least 75 feet from the storage. So sometimes that can be a bit of a challenge depending on your site. And then here's your emergency relief valve over here on that particular storage. This actually is a picture of Dale's cover that was done in 2012. Rainwater discharge points that you can see here, that flare location that he had here. And the main reason I wanted to show this, there was a couple different things on this site. One, this was a retrofit and they had these access pump out locations installed before the cover went on. So to attach that, instead of just going into a stabilization trench, you have to come up with a way to seal that to the concrete. So this is just the detail that we use to seal it to the concrete, but definitely something to keep in mind. And then the other reason I wanted to show it was the potential for silage leaves to get down onto this cover and potentially contaminate that cover. It's something you really need to think about during design, but also if you're going to be discharging that water, you need to be thinking about, Dale collects all of his and uses it for irrigation, so there's no issue there. But if he was discharging that to clean water, it's something when you're turning those pumps on, you need to really pay attention to. This is the finished product of the retrofit that I showed you all the photos of. You can see a lot of gas production on this one. This is another retrofit with solid separation installed. So this farm did not separate solids. They installed the separation building. Flare location here, access point here that was installed in 2016 prior to the cover in 2017. And then this is the one I was talking about where we had an issue with clean water exclusions. There's a diversion here. This is the manure storage prior to cover because I could not get a photo recent enough to show the cover. This is a retrofit in 2020. There was a diversion here that had silted in. That diversion carried all the clean water from this hillside around the manure storage. And when it silted in, they had just installed this cover and we had a 5-inch rainfall in about an hour and a half in this location. And they ended up with 5 feet of water. That's why the cover looks dirty on top. That's all silt from the hillside that came in about 5 feet deep. And the cover was not even, the pumps weren't even installed yet. So it was a real wake up call to the farm, how much water they could have potentially been adding extra every time we had a rainfall event to their storage. And we obviously took care of that diversion at the same time. This one also, that flare location is upslope. Was a nice site. We put the flare location upslope and we're able to drain the condensate right back into the storage. So this is the issues we were talking about, potential contaminants from the surrounding areas. I wanted to kind of just give you an overview of some of the issues that we've seen. This is Dale's again, the silage leachate issue we talked about. And then this is the double cover with the manure solids stacked right here. When the wind blows, there's a potential for those manure solids to get right onto that cover. This is the storage that was installed from new down here on the bottom. And you can see if you look closely, the color in this clean water collection trench and the color in this clean water collection trench do not match. This cover received damage in the springtime from an ice sheet. So the ice had built up on the side, ice sheet fell down and perforated the cover. So the installer came back and repaired it. So there was no issue, but they had to pump this rainwater obviously back into their manure system. This cover, they had some issues with the flare when they first started up. So one of the harder things to do, this is an earthen storage, no synthetic liner. And they had leaks around the stabilization trench where for one reason or another, it did not seal well. So they weren't getting enough gas production to make the flare run consistently. So that was all repaired and now is working fine, but that was an issue with that site. And this is the one I was showing you with all the gas production over here at the bottom right. You can see how high. That is not how a cover should look. This site had excessive gas production, a couple of different issues. The separation was not working well. And so there was excess solids in there, but even calculating that out, there's an anomaly here that we still have yet to figure out exactly why there was so much gas production in this storage. It is in a location where it sits over here, there's a natural gas well, and this storage, when they constructed it prior to my involvement, did hit shale in this lower corner that was lined with clay. Maybe there's something there, I don't know, but that's something, one of those issues that you need to keep in mind when you're doing things and why it's so very important to have an emergency relief valve. So that concludes my presentation. I'm going to stop sharing the screen, Jennifer.
All right. So thank you so much, Jennifer. Jessica. Thank you so much. That was fantastic presentation. We are running low on time, but there are a couple questions I wanted to see if we could field. Is there a book estimate of the cubic feet of methane per cow from a covered storage or potential BTU per cow if a flare is utilized for energy use? Like, how do you do those calculations for how much gas is going to be produced?
There is a book value that I don't know off of the top of my head that we use when we calculate that. And it does depend on separation and how much separation you have and how efficient your separation is, what that number is. But it does need to be calculated so that you can decide whether or not you need a blower to deliver the gas more quickly to the flare. And it helps you size, obviously, the lines to the flare, the blower itself, and the flare.
Fantastic. So John asks, how are we dealing with covers and flares on steel and concrete tanks compared to earthen lagoons?
We've done none in New York that I'm aware of.
Of the steel ones, steel and concrete.
Steel or concrete. So concrete poses some issues with covering. Earthen are very easy to cover. Concrete, you have the vertical sides. The only time we've tried to cover one was for rainwater control. And so we could figure out a way to do that, but not a way to make it reliably sealed to the top of the tank for gas collection. So we have not done one of those yet. And same with the slurry store, we just haven't come across it where anybody has wanted to put a flare on a slurry store. So I'm certain it could be done, but it's not something we've done yet.
Okay. If you want to answer any of those questions in the chat by text, please do, but I also know that you need to leave. So thank you so much, Jessica. That was a super presentation. I'm so happy we could have you join us today.
This has been a production of Cornell University, on the web at cornell.edu.